Hey guys, in this section, we're going to start talking about the properties and reactions of alkanes. So first off, we're just going to talk about the properties. So in general, alkanes are chemically bonded, covalently bonded, word started with a C. Mostly we're going to have sharing of electrons, not necessarily ionic bonds. We have low melting points, low boiling points. I'm missing a bullet here, but there's a bullet that should say flammable. They are soluble in nonpolar solvents, but insoluble in water, and they're typically less dense than water. Whoa, I didn't see that word there. Typically less dense than water, so they often will float in water. Some examples of alkanes in your everyday lives, and properties associated with them. C1 through C4. So if you have one carbon, methane through butane, C4, they're typically gases at room temperature, and these are used almost solely as fuels. An example of this is propane gas. So this is like the gas tank that you use in your grill if you use a gas grill. And that's what causes the fire and flames and everything that you have. For C5 through C8, they're typically liquids at room temp, and they're very volatile though. So what that means is that they readily go from a liquid to a gas at pretty low boiling points. So as they're sitting there, they could evaporate. And these are also traditionally used as fuels. An example of this is gasoline, which I think many of you experience all the time in your everyday lives. Carbons 9 through 17, so now we're getting pretty big in terms of our carbon chain length. They are typically also liquids at room temperature, but they have higher boiling points. So they're not volatile like the C5 through C8 carbon lengths are. They're typically used as fuels or lubricants. So for example, we have a kerosene lamp, or we also have motor oil. Both of these things are very similar in terms of their properties. They are alkanes that either burn well or help grease things up. A lot of the times we just call alkanes, like in the lab, we just refer to them as grease. And our last one is C18 plus. They are waxy solids at room temperature. They are typically used as wax coatings or lubricants. So things like grease or Vaseline, or even the wax on top of the apples that you get at the grocery store to help them look shiny and keep them all nice and bright color. Those are all alkane chains. They're just really large alkanes. So some safety associated with alkanes is specifically their flash points. So when we're looking at things, really almost all of them, but particularly the smaller carbon count alkanes, we have to worry about their flash point. Their flash point is the lowest temperature at which vapors above a combustible substance will ignite in air when exposed to flame. What this means is if you have, let's say, a bottle of hexanes, so 6 carbons long, there's going to be some of the hexanes that have turned into a gas on top of it. So there's kind of an equilibrium between them, but it's going to be volatile. It's going to be turning into gas over time. And this flash point is at what temperature that the flame is required on the gases above that material to set everything on fire, pretty much to blow it up. Um, so, for example, you have pentane's flash point is at negative 49 degrees Celsius. So, pretty much, even any kind of flame at all is going to set pentane on fire. So, we actually had, I have personal experience with this, not necessarily me personally, but one of my lab mates accidentally started a pentane fire about 4 years ago. And it was really scary. And her entire fume hood and her area that she was worked in was charred to the brim. Everything was destroyed. And it was a very fast fire. It burned really, really quickly, but it's still really scary. So I will not do that ever, hopefully. Hexane's flash point is negative 22 degrees Celsius, and heptane's flash point is negative 4 degrees Celsius. So all of these uh, alkanes here, if you have any kind of flame, they're going to ignite. Okay, so this is where this video is going to stop. And our last video for this lecture is going to talk about our reactions of alkanes.